Okay, guys, so let's actually apply the limit definition of the derivative and see how it's useful. So again, we said the derivative gives us the slope of tangent lines. So let's look at this first example. So I want the slope of the tangent line to this curve when x equals 1. So you can imagine we have some graph. At the point where x equals 1, I want to know what is the slope of that tangent line. So we have our limit definition of the derivative, which I'm going to write for us again. And so now all we have to do is use this. We have to substitute stuff in. So it's telling us exactly what to do. I'm going to plug this into my function to start. So this is equal to the limit as delta x approaches 0 of, if I plug all that into this function, I have 3 minus 2 times x plus delta x minus 2 times x plus delta x squared minus that whole function. So this part is the part in red, minus 3 minus 2x minus 2x squared. And all of this is over delta x. So let's see what's going to happen with it. I'm going to put myself here just for a bit. We actually have to do all the algebra. As we always say, the most grueling part of calculus isn't the calculus. Once we get the ideas, they're cool. It's really the algebra. So we have, if I do this whole thing in red, I have 3 minus 2x minus 2 delta x. This piece right here, what is that? That's going to be minus 2x squared plus 2x delta x plus delta x squared. So that's going to be minus 2x squared minus 4x delta x minus 2 delta x squared. And then this whole part is going to be minus 3 minus 2x plus 2x, right? We're distributing that negative, plus 2x squared. You're going to see a lot of beautiful things happen in this situation. We have the 3's go away. We have the 2x, then minus 2x, then plus 2x goes away. We have these go away. And so what we're left with, let me see if I can make all of this a little smaller. Okay, I can't make it smaller right now, that's okay. I'm gonna just continue to write. And then I want it in black. Limit as delta x approaches 0 of negative 2 delta x minus 4x. 4x delta x minus 2 delta x squared over delta x. This still is a problem because I'm going to plug in the 0 here, but watch how I'm going to get rid of this delta x. If I factor, I can factor one out in the numerator. Which makes this go away. Now all I have to do is plug in delta x as it approaches 0. Since this is a polynomial, I can just plug in delta x as it goes to 0. This goes to 0. Remember, the x can stay in the limit answer because it's not actually part of... Where'd my face go, by the way? Do you guys still see me? Yeah, there I am. I'm going to move me one more time. Because the x isn't in the limit. So all that's left is negative 2 minus 4x. This is the derivative of this function up here. So now if I want to find the slope of the tangent line at x equals 1, all I have to do is plug in 1 into this equation. So what I'm going to do is I'm going to add a page. So we just found out that the derivative is negative 2 minus 4x. And we knew the function was, just to make sure, 3 minus 2x minus 2x squared. Another way we can write the derivative is we put this little symbol here. We call this f prime of x. And now I want to know right at 1. So I'm going to plug in 1. What is the derivative? Negative 2 minus 4 is negative 6. So what that means is the slope of the tangent line at that point is negative 6. Let's take a look at that. I'm actually going to open up Desmos. So our original function was 3 minus 2x minus 2x squared, right? Here's our lovely parabola. And we wanted to know right at this point, right? What was the slope of the tangent line? Well, if I go back now to this, I know the slope is negative 6. So if I want the tangent line, I want the line at 1 minus 2. So I want the line at 1, negative 1 with a slope of negative 6. We know how to do that. We took Algebra 1. So we're going to use point-slope form. So we have y minus y1 equals m times x minus x1. This allows me to write the tangent line. If I plug everything I know, I have my point. Y minus y1 is negative 1, so that's y plus 1. My slope is negative 6, so that's x minus 1. This is the equation of the tangent line. Let's see if that's true. If I do y plus 1 equals negative 6 times x minus 1, look at that, guys. There it is. That's the only point that it goes through. It's tangent to it, which means we have our tangent line.